In this video, we'll look at how we solve for the linear equation when we're given a point on the line and the y-intercept. Here we have 10 example problems. In each example, we have a point and the y-intercept b. I'll walk you through the first 5 example problems, and I'll give you the solution to all 10 of these at the end of the video so you can work through the last 5 on your own. So as we solve for the linear equation, remember that we're given a point and a y-intercept. We can think of the y-intercept also as another point. Now remember that points are defined as x comma y. So the first number is our x value, the horizontal value. The second number is our y value, our vertical axis value. And remember our linear equation is y equals mx plus b, where m and b are our constants. We're given our y-intercept already, that's the b term. So all we're solving for is the slope, the m term. Remember that the slope is rise over run, or delta y over delta x. And we're given a point. So we're going to use subscripts x1 and y1 to represent the points x value and the y value of that point 1. And b, the y-intercept, can also be interpreted as a secondary point of 0, comma b, because the x value of the y-intercept is 0 and the y value of the y-intercept is b. So if I write the slope equation, m as delta y, that's y1 minus b, right? The y value of point 1 minus the y value of the y-intercept divided by delta x, x1 minus 0, that's the x value of point 1, and 0 is the x value of the y-intercept. We get the slope equation as just y1 minus b over x1. For our first problem, we have a point of 1, 7 and a y-intercept of 2. So we use the slope equation that we set up, and we use y1 minus b, which would be 7 minus 2, divide by x1, which is just 1. So we can get our slope of 5. And all we need to do now is plug in the slope and y-intercept for the y equals mx plus b equation. So we get y equals the slope of 5x plus the y-intercept 2. So you can see how this is actually a pretty straightforward problem. It's just that one equation for the slope. And when we graph it, we can see if we graph the line correctly, we have the point 1, 7, and then we see that it crosses the y-intercept at point 2. Right? We'll do the same thing for problem 2. Here we use non-round numbers, right? Decimal values, negative 0.2 and 0.4 for our point 1 and y-intercept of 1. It's the same exact process. We'll say y1 minus b, which will be 0.4 minus 1, and then divide that by negative 0.2 for our x1 value. So for our numerator, we'll get negative 0.6, denominator negative 0.2. The signs cancel each other out, and we get 3 for our slope. And so we get a linear equation of 3x plus 1. And if we graph this line, we see that our point negative 0.2 for x, positive 0.4 for y is right here. And then we cross the y-axis right here at 0, comma 1. And so that's our y-intercept 1. Now let's take a look at problem 3. We have a x value of 8 and a y value of negative 4 1/3 and a y-intercept value of negative 1/3. So I'll solve for my slope. y1 minus b is going to be negative 4 1/3 plus 1/3, because it's negative minus a negative value, and then divide that by 8, my x1 value. Negative 4 1/3 plus 1/3 gives me negative 4. Negative 4 divided by 8 is going to give me negative 1/2. So I'll just plug this slope and y-intercept into my linear equation. So y is equal to negative 1/2 x minus 1/3. Okay, so look at my graph. There's my graphed line of what I think my solution is. There's the point 8, negative 4 1/3, and then I can see that it intersects with my y-intercept of negative 1/3. So it's easy to check with a graphing calculator or an online graphing calculator. Let's take a look at problem 4. Problem 4, we have a point of 4, 2 and a y-intercept of 2. So something interesting here, our y-intercept is the same value as our y value. What does that tell you? If you have 2 points on a straight line that have the same y value, that means the line has to stay along that y value again. Why is that interesting? Well, what does that tell you about the slope? What does that tell you about the type of line? Well, if you put this into the slope equation, hopefully you recognize that you'll get a slope of 0. And if you watch the previous videos, hopefully you'll recognize that a slope of 0 gives you a horizontal line. So let's go through that process. y1 minus b would be 2 minus 2, which will give us 0 for the numerator. And x1 of 4 would just give us 4 for our denominator. So this gives me a slope of 0, which is consistent with what we would expect. And if I plug this into my linear equation, mx plus b equals y, what would this give us? 0 times x will give us 0 for the mx component. And this would mean that y is just equal to b, or y is equal to 2. Well, this is a horizontal line, right? So you're saying that y is equal to no matter what x is equal to. So our graph looks like this. There's my horizontal line. There's my point 4, 2, and there's my point for the y-intercept. So it's consistent with what we would expect. All right, let's look at one last problem, problem 5. Problem 5, we have -3, -3 as our point, and -2 as our y-intercept. We're going to repeat the process that we've done a number of times already. Our numerator for our slope will be -3 minus -2, and our x1 value is -3. So our numerator will be -1, our denominator will be -3, which will give us a slope of 1/3. So if I plug this into my linear equation, I get y equals 1/3 x minus 2. So we take a look at our graph again, we'll see here's our point, -3, -3, and then here's our y-intercept at -2. So you can see the process is relatively straightforward once we know our equation for the slope. So in this video, we went through these first 5 problems. Take some time to make sure that you understand the equation that's being used and where that equation comes from. Then make an attempt at these 5 problems, and then you can come back and check to see if you match the solution for the linear equation. Essentially, do you match the slope that you're asked to solve for?